So we did a confidence interval on how much TV college students watch each day based on a sample from my current statistics students. Again, that's not a representative sample, but we're playing with it anyway because it's live, real data. And this is a tough question to wrap one's mind around. So again, problems here were, what does it mean to watch TV? And I said, well, it's recorded videos, streaming services, games, blah, blah, blah. Now, I think our cell phones complicate this a little bit. Cell phone is a television, right? You have moving pictures on your phone. And so I did some research about this to see what's going on. And I also asked you all in a survey recently. So let's bring this in. So I asked you to tell me what you thought on average college students watch. And some of you misinterpreted this question to say, how much do I watch? But the question here is how much TV do college students watch each day on average? And I wanted you to make your best guess. And some of you researched it and came back with your research. Other people said, I watch 10 hours per day, or not, nobody watches 10 hours per day, really, do they? That's sad, I don't think so. 3 or 4 or whatever. So the question really is, what do you think the national average is for college students? And I was reminding you that I asked you this question at the beginning of the quarter. So we already took a look at that data for a confidence interval. Now we're going to jump to a hypothesis test. So the question is, what do we think the national average might be? So based on your responses here, and again, not everyone that I asked this question to answered the right question, but we have a range of half an hour to 8 hours per day, centering at around 3 hours per day here. According to your responses. If I weed out the ones where you were saying, I watch this much, the distribution wouldn't be quite as wide. And I still think it would be centered around 3 based on my discussion with some of you all in class. All right, so some other things. I went to the US Census Bureau and they have a time usage survey where they ask people, how much time do you spend doing all these different activities each day? And there's a ton of activities they ask people about, from sleeping to grooming to eating to cooking to walking, going to church, things like that. And under the leisure and sports section, they have a watching TV here. And they also have a computer use for leisure, which is also part of what I asked. So if I take their 2 numbers for watching TV, 2.81 hours, and computer usage for recreation, that's about 0.17 hours, I get 2.98 hours. So almost 3 hours per day. This is a 2019 survey from the Census Bureau. So here I get almost 3 hours per day from that 2019 survey. Article here was data from 2019, 2020, and they talk about average television per day of about 3.1 hours. They also talk about recreation, including TV, where it went up during the pandemic to about 5.5 hours from where it was 5 hours before. Now that's not just TV time, that's other stuff too. Others, Statista had minutes of TV watched in the US, and in 2022, they said it was about 181, which is just a hair over 3 hours. During the pandemic, it was a bit higher. And then a study from Nielsen reporting. Nielsen is a company that does surveys for media companies. They had said a bunch of different things about it. And they also talk about things like smartphone usage. So does all smartphone usage count? Well, my daughter spends an inordinate amount of time watching TikTok and Snapchat videos. Does that count? I think so. Playing games on her phone and things like that. And that's been up dramatically over the last couple of years as smartphones have become bigger and more colorful and more addictive. So it's a tough question to answer, is my point here. So what can we do with it? Let's take some notes and see what we got. So hypothesis test with the central limit theorem. I'm trying to answer the question, do college students watch less TV per day than adults in the US? Why am I asking about less? Well, I think college students tend to be busier with college and life than your average adult who just has a job and a family to take care of. So I'm thinking they watch a little less than the average adult. So what are we going to go with for the average adult? Well, based on those other ones for 2022, I think that on average, adults watch about 3 hours per day. Is what I'm going to go with. And then I have my question here, which is that they watch less. So if I think about my question says, and basically I don't mention the word average in my question, but it's got to be average, right? What else could it be? It could be median, but we're going to go with average. So my question says, is mu less than, and based on what I think the national average is around now, 3. That's got to be the alternative because it does not have an equal sign in it. I'm guessing, based on the research I did, all the articles I looked at, that the null hypothesis, the mu is 3 hours per day. So those are my hypotheses. I'm going to go for a standard significance level of 5%. Based on my alternative hypothesis, I'm going to run a left tail test. Other things to consider. We're going to use the central limit theorem here. And the central limit theorem says that the standard error for such situations is approximately equal to the standard deviation of your sample divided by the square root of the sample size. Based on the standard deviation, I'm going to calculate a t-score, which is like a z-score. I'm going to take my sample mean, subtract the population mean, divide by the standard error, which is s over the square root of n. And then based on that t-score, I can calculate a p-value. And that p-value is going to be based on a t-distribution, which I could do in a spreadsheet or in StatKey's t-distribution. Let's give it a shot. So we need data to do this. And I have data somewhere here. We're going to go with the hours of TV per day from my 2022 students. And I'm jumping into the copy of sheet 2 because in the original data, somebody claimed to watch 10 hours per day, and I think they were going per week. So I pulled that number out. So I'm going to grab the numbers from the copy here. So I need to highlight and copy those. And I'm going to put them into the spreadsheet I shared with you earlier that has a tab for just about anything you want to do with basic inferential statistics and the central limit theorem. So here I was earlier with central confidence interval for a mean with data. Jump over a little bit, you should see hypothesis mean with data. And here last time it looks like I was doing Pendleton home prices. So let's get rid of that. This is hours of TV per day. It's always good to put in a label, make sure you know what you're talking about. And then highlight all of the existing data and delete it. And then paste in your other data. All right, so what do I got? I got my sample size of 32, that looks right. I can see that the mean is 2.1753, that's what I remember from before. The standard deviation to 2 decimal places is 1.04, but I can always ask for more decimal places if I want to. Let's take these down to maybe 4 decimal places. Should be good enough for this. I'm going with alpha, my significance level of 0.05 there. And I got to set my mean. So let's see, mu, we're thinking is 3. We are doing a left tail test. And this is just for my reference. The spreadsheet doesn't care what I type here, but it does care about the data and the alpha. All right, yep, and that means I'm going to do a left tail test. Okay, so what do we got here? We have a standard error of about 0.1833, and that standard error is based on the sample standard deviation and the sample size. We saw that before with the confidence interval. And this predicts the t-score is about -4.4999. That's a pretty big t-score. So remember, think about t-scores like a z-score. We expect most data to be within 2 standard deviations. This says it's like 4.5 standard deviations below average. That's way below average, okay? If I consider the left tail probability here, I get 0.000004 something. It's a pretty damn small p-value. All right, let's sketch this out in our notes. Please sketch these out when you work on them. So what do we have? Let's put in red up here my sample data. So from the sample, I need to know the count. That was 32. I need to know what X bar was approximately. According to the spreadsheet, that was about 2.1753-ish hours per day. And the sample standard deviation was about 1.0367 hours per day. Now, based on these values here, my spreadsheet is calculating the standard error, which we got to be about 0.1833. And the spreadsheet calculated the t-score to be about -4.4999. Based on that t-score, we got a p-value of about 0. How many zeros were there? 4 zeros? 1, 2, 3, 4, 4. That's wicked small, right? That's way less than alpha. So note over here, my p-value of 0.00004 is way less than alpha. So my decision here should be to reject. Remember, if p is low, the null must go. Reject the null. Quick sketch of what this looks like, and we'll ask stat key for a sketch too. When we do a hypothesis test, the center is whatever the null says. So the null says center this at 3. We expect people to watch about 3 hours per day. So the question is, where does 2.17 or 18 fall by 3? And so it's this standard error that helps us figure out what the scale is. Is 2 over here, or is it way out here? Turns out the 2 is way out about here, I would guess. That's my 2.17. That's my X bar. This is my mu right here, mu. And my p-value is the percent of other similar samples I expect to be less than mine when I expect the mean to be 3. And that p-value again is 0.12344. Let's ask StatKey what it thinks to confirm my graph. So to do this in StatKey, there's a couple ways we can do it. We can just use their t-distribution. So I'll do that first. And to use the t-distribution, I just need the sample size and the z-score. So back to StatKey. Uh-oh, StatKey's not happy with me. Has ever happened to you? Give me a sec. Maybe I need a new tab. All right, let's try a new tab. StatKey. There we go. Theoretical t, because I'm using a mean. You use t's. Degrees of freedom. What's that again? Sample size -1. So I had a sample of 32. I enter 31. And then I'm doing a left tail test. And then I put my z-score down here. Why down to the left? Because it's a left tail test. -4.4999. And StatKey says, ooh, that's a little p-value. Look at that, 0.000045, which if I choose to round in my spreadsheet, that's about what I would get there too. So this is applying the central limit theorem. The way we did it before was just doing a randomization distribution. To do that, we would highlight the original data. Is this stat key going to come back to me? Here's the other stat key. Do a hypothesis test for mean. Edit in your data. I didn't have a header row here. Double check I got the right data. 32 numbers. Mean of 2.175, standard deviation of 1.037, check. We got to set the null hypothesis. It's not 98.6, it is 3. And then we run thousands of samples. And we should get similar numbers, not exactly the same for 2 reasons. I have 32 items in my sample, which is close to 30. Bigger sample size gives you better results. And left tail. And we enter our sample mean 2.175. And that is off my screen there. And StatKey says, I didn't find any other samples like that one. Probability is about 0. And the 3 decimal places, right? That is about 0 right there. So what is our decision? Definitely reject the null. What's our conclusion? Well, it seems that there's significant evidence that on average, college students watch significantly less than 3 hours per day. Check. Thank you for playing. Hope this was helpful. Have a good day. Do good math.